that is left now. Rest of the chapters, thermal unit is 4. If you have any doubts, you can ask me right now also, or even after the end of the class. Okay. See, before I begin, there are these few basic trigonometric functions that we all are aware of. So it's just that you should note them because this will be used a lot. Trigonometry is used a lot in SHM. So see, few relations like this, sine value of sine 30, value of sine 45, sine 60, sine 90, all these you remember. What you have to remember, value of 270, sine 270, value of sine 360, and all these things. So just note down these because there's nothing to explain in over here. Wherever you want me to explain, just let me know. And see, regarding these also, these you all are already, you have learned them. And remember this also. 1 degree is pi by 180 radians. All right, so just copy the trigonometric functions, then we will understand what is oscillations, what is SHM. Aisha, is your network fine? Can you unmute yourself? All right. So have you revised thermal expansion?
Yes, ma'am.
All right. So as I was discussing with Akifa, can you tell me what is triple point? Triple point of water we had seen. Yes, Aisha, what happened? Okay, I think she's having a network issue. Fine, Akifa, you keep on noting down all this. If she come, I'll take her viva. Otherwise, you just note it down and let me when I have to scroll it down. Yes, Aisha, is the network fine now?
Yes, ma'am.
All right. So yes, tell me what is triple point?
The triple point is the temperature and the pressure at which all the three states are in coexisting.
Coexist in equilibrium, all the three states of matter. Yes, exactly right. Okay, so what was the formula for temperature at triple point?
Temperature
Value, the formula for calculation.
RP into P divided by PTRP.
Can you repeat? Can you repeat, please?
PTRP into P divided by PTRP.
See, it is 273.1 multiplied by the pressure, then divided by the pressure that is given at triple point. All right. Okay, so tell me what is the formula for heat, specific heat capacity? C that we used to represent it.
Specific. I was not there during that class.
Yes, what I say?
I was not there during that class.
Okay, so please revise all these topics which you have skipped or whatever has missed because see, not much time is left now, right? So you should revise all the previous topics. So which classes did you take from thermal? Last classes.
Thermal,
Yes,
it was from thermal expansion.
thermal expansion in liquids, I think.
Yes.
All right, you have missed thermal expansion in solids.
Yes.
All right, all right. Fine. So tell me, what is the formula for apparent volume? Okay, tell me, explain me the thermal variation in liquids. Explain me what I've told you.
Thermal expansion is the expansion of liquid in the container, and then delta V equals to V
You see,
square
we
by.
had seen two cases. We had seen two cases. One in which
Yes,
the
sir.
yes, yes. Say
Two. There were three cases.
Yes. Yes, there were those three cases. I am saying what is meant by apparent expansion, what is meant by real expansion. These were the two major cases which we studied. What was apparent expansion? What is real expansion?
Apparent expansion is the container also expands in apparent expansion.
And real?
In real expansion, the liquid expands.
In real expansion, only
Liquid.
only the liquid expands, right? So what is the formula for coefficient of real expansion?
Is it delta V is equals to V square minus V1?
You are telling me the formula for delta V, that is change in volume. I am asking you for the coefficient of real expansion. Coefficient.
It's increase in real expansion by the original volume into delta T.
Yes. And the coefficient of apparent expansion?
It is the opposite increase in V by the original V into delta T.
Apparent increase in the volume by the original volume per change in temperature or per degree rise in temperature. So have you studied latent heat?
Latent heat. Yes, ma'am.
So tell me what is meant by latent heat? How do we calculate it?
Latent is the amount of heat required to change the unit mass of a substance from one state to another.
Yes. Change of state is there when the temperature remains constant. So what is the formula of latent heat?
Latent heat formula delta Q is equals to mLF or mLV.
See, latent heat is that L. So if when you are asked the formula for latent heat, you should write L is equal to Q by M. As Q is equal to ml, so L will be what? Q divided by M. All right. Okay, what was the principle of calorimetry, Aisha?
Calorimetry, it is an experimental technique for
Yes, but what
quantitative
was the principle of it?
law of heat exchange.
Law of heat exchange, which says that
Like if heat lost is equals to heat gain.
yes, good. Heat loss is equal to heat gain. Aisha, just revise all those topics which you have missed. All right, because
Okay.
oscillations and waves, these are huge topics. Right now, we were doing little topics like kinetic theory was not a bigger chapter. So just revise all those that have been missed. Fine.
Okay.
Okay, see, we have started with oscillations, SHM. So before moving into the details, what is SHM, periodic oscillatory motion, just note down all the trigonometric formulas which you are not aware of. Because see, sine 30, sine 40, sine, I have written this in advance just as if you don't know, in like sine 270, sine 360, whichever you are not aware of, you can write it yourself. Then we'll begin with it. Let me know when you both are done.
Done, ma'am.
Ma'am, can you scroll up? Done, ma'am. Done, ma'am.
Both of you?
Done, ma'am.
All right. So let's understand what is SHM, what is meant by periodic motion, what is meant by oscillate. See, okay, so far what all topics we have covered. And apart from this also, you must have studied translational motion, you must have studied rotational motion. Now you have to understand the important kinds of motion like oscillatory motion, vibratory motion. What are these kinds of motion? So an important type of oscillatory motion is SHM, simple harmonic motion, for which displacement graph is plotted. It's a cosine graph, and that is we'll be discussing in detail today. See, first is periodic motion. The motion which repeats itself after a regular interval of time is called periodic motion. So the regular time interval is called time period of the periodic motion. Like for example, the rotation of Earth on its axis. If this is the axis of the Earth, if it rotates, if the Earth rotates, what happens? Let's say if this is the starting point, then what happens? The Earth rotates itself on this axis, and after 24 hours, after the completion of 24 hours, after this one completion, it reaches this point again. Then we say this 24 hours is the time period of the periodic motion. Why is it a periodic motion? See, the Earth doesn't stop over here. It will again begin its rotatory motion around the central axis when the time gets completed is 24 hours. Then again, after this fixed time, that is 24 hours, the Earth knows that it has to rotate itself around this axis. So even if it started from this point, it will rotate till when? Till it reaches this point back through rotation, and the time period through which it rotates, this is 24 hours. So this motion, this rotation of Earth, this is after a regular interval of time. What is that regular interval of time? That is 24 hours. Earth knows that it has to come back to its original place, original point of initiation, when? After 24 hours. So these kind of motions are known as periodic motion, where there is a fixed regular time interval and the motion keeps on repeating itself. See, regarding Earth, the Earth doesn't stop over here. Earth completes its rotation again. So that's why we say this motion is periodic. Or you can take the example of revolution of Earth around the Sun. If Sun is there at the center, this is the orbit of the Sun. The Earth, let's say this Earth has started from this point, point A. Then after revolving around the Sun, after completing this elliptical path, the Earth reaches back to this point A, and we say the duration is 365 days. 365 days or 1 year. So again, now the Earth doesn't stop over here. What happens? The Earth begins its motion again. It will again revolve around the Sun and come back to its initial point A. So that's why we say this motion is periodic. So all the motion, like you can say the revolution of Moon around the Earth is periodic motion. So it's a, and why we say the revolution of Moon around the Earth is a periodic motion? Because we know that after 27.3 days, the Moon will again revolve around the Earth. It won't stop over there. So this repetition, this constant repetition of motion after a certain interval of time like this is known as the periodic motion. And these time intervals that we have been discussing, 24 hours for rotation of Earth, 365 days for revolution of Earth around Sun, 27.3 days for the revolution of Moon around Earth, these fixed interval of time, these are known as the time period of the periodic motion. Clear?
Yes, ma'am.
Now see, what is oscillatory motion? See, all objects that vibrate or oscillate have one common thing. So that let's discuss later. First, let us understand what is this oscillatory motion all about. See, it's a type of periodic motion only. Periodic motion only means what? It will repeat itself after a regular interval of time and it will have a certain time period. Just the difference comes in the pattern of motion. As in, if the particle or the body, whatever is the object, it repeats its motion, periodic motion, from the path that is about a definite point. Like you can say the path of pendulum. Okay, pendulum is what? It's a long thread that has bob attached at its screen and the other end is fixed, or we hold it from where the point of rotation occurs. Now see, if this is the pendulum, let's say, so this is the mean position. Mean position is the starting position from where the particle has been released. The initial position after which the particle comes to rest is known as the mean position. So what happens if you apply a little force over this pendulum? What will happen? This will reach its extreme point, then it will come back to its mean position. That means then again it will go to its extreme point and it will reach its mean position back. See the motion. I'll draw it with a different color. Just note down the motion. See, first it will go to its extreme, then it will come back to its mean, From the mean, it will again go back to extreme. And from the extreme, ultimately, it will return to the mean position. This is known as one oscillation. Why is it known as one oscillation? Because the motion is to and fro about a definite point. Let's say mean position is our reference point. This is our definite point. So the to and fro motion, that is this back and forth motion, this is known as the oscillatory motion. Or you can take another example of spring. If this is the mean position of a spring and a block of mass m is attached at the free end of the spring. If I apply a force over here, then what will happen? This will expand. If I apply a force in this direction, the right hand side, it will expand. Then when I release it from this point, what will happen? This block will compress the spring first. So the spring will go to and fro, that is back and forth. So this motion, this type of motion is periodic. Definitely it's periodic. Why? Because it is repeating itself within a certain interval of time. But this pattern of movement, that is object is moving to and fro, this is known as the oscillatory motion. So oscillatory motions are what? Periodic. All the oscillatory motions will definitely be periodic. Why? Because these will be exhibiting all the characteristics of periodic motion. But see, all periodic motions cannot be oscillatory motion. The rotation of earth is not an oscillatory motion. The revolution of earth around the sun is not oscillatory motion. The earth does not oscillate around the sun. We all know it revolutes around the sun. It revolves around the sun. So that's why we say all oscillatory motions are periodic, definitely. But all the periodic motions cannot be oscillatory. Those motions which repeat around a path to and fro, those are only considered under oscillatory motion. So see, each object is subjected to a restoring force that increases with the increase in displacement from the equilibrium position. So a restoring force is one that tries to pull or push a displaced object. Like in this case, the restoring force will act, that will try to put it back to its mean position. This is known as the oscillatory motion, and the previous, this one, is known as the periodic motion. So are these clear? Periodic motion, oscillatory motion.
Yes, ma'am.
Yes, ma'am.
Okay, see what is meant by simple harmonic motion. See, simple harmonic motion is now a type of oscillatory motion. So a simple harmonic motion is an important type of oscillatory motion. And if we wish to define it, it will be a particle is said to execute SHM if it moves to and fro about the mean position. The characteristics of oscillatory motion: to and fro about the mean position or the equilibrium position in a straight line. But the condition is that the graph between displacement of the particle from the equilibrium position is a sine or cosine curve. So in simple harmonic motion, the oscillatory motion of the particle is in a straight line such that its displacement from the equilibrium position or this mean position, this varies sinusoidally or cosinusoidally. That is, it can be a sine curve or a cosine curve. So this is the simplest type of periodic motion, or you can simply say harmonic motion, or in simple terms, it is known as the simple harmonic motion. Is the basic theory clear to all of you?
Yes, ma'am.
Just note down the definitions. Okay, just let us see a few examples of SHM also. We have seen for oscillatory. See, pendulum's motion can be SHM. All the conditions are being followed. Oscillation of a spring is also SHM. See, SHM is a type of oscillatory motion only. So that's why example of pendulum, example of spring will be considered again under simple oscillatory motion. Also, one more thing that is different is liquid in a U-shaped tube. U-shaped tube we have discussed in fluid. We have seen numericals also in this U-shaped tube. So liquid in a U-shaped tube, it when you apply a force, this also oscillates to and fro like this. So it's also a kind of simple harmonic motion. One more thing is that in case of the conditions for SHM, what happens is restoring force that occurs. Let's say this is a spring. This is the mean position. This is the mean position. I have stretched the spring and it has reached to this point. So there is this extension. Are you able to observe this stretch? This green line that I have marked. Yes or no?
Yes, ma'am.
Aisha, you there in the class? Aisha, see, now see, X is the extension produced from this mean position. So whatever is this restoring force, whatever is the restoring force applied that will try to bring this object back to its mean position, this is directly proportional to the extension produced. So if I tell you what are the conditions of SHM, first, as usual, it is an oscillatory motion. Rest of the conditions will be satisfied. The other point is that this restoring force is should act towards the mean position. Obviously, that's why only it will try to move the object back to its original position unless and until the restoring force is applied towards the mean position only. Then only the object will be able to retract back to its mean position. So, and the third point for fulfilling the requirement of SHM is that this restoring force is the restoring force. This restoring force is directly proportional to the extension produced or the displacement from the mean position, and the constant that we get is known as the spring factor. So we will see various systems, spring system, then different kinds of system we'll see. What happens is that just the value of this constant change. For spring, it will be spring constant. It's just that it's a constant named as spring factor. For various objects, this k will be having its different value. So these three conditions of SHM, are these clear?
Yes, ma'am.
Just note down these first.
Ma'am, can you scroll?
Ma'am, can you scroll down? Ma'am, can you explain this topic again?
Which one? Which one? This SHM.
Yes,
SHM
ma'am.
part or the conditions one?
Conditions of it.
Conditions of SHM. Okay, see oscillatory motion, as we have discussed, that if a body is in periodic motion, it moves along the same path, that is to and fro about a definite point. This to and fro movement, I hope you understand, like this. About the center point, object moves like this. So this is known as to and fro, when the object moves back and forth from a point. See, the first condition of SHM, if you have given, you are provided with a system, you are given any condition, then how will you identify whether the particle is exerting simple harmonic motion or not? First, you will check whether it is oscillatory or not. All right. Now, see, mathematically, we'll see all the things, how to prove that anything is directly linked to SHM. Is it periodic? Is it harmonic or not? That we'll see later on. But just in order to identify the basic rough conditions for SHM. So first becomes this oscillatory motion, that SHM is a type of oscillatory motion only. This means like the case of spring or like the case of pendulum, what we have seen. In this, the object or the bob of the pendulum, this move, like in this example, this move around this mean position. This is the center position, this mean position. All right. So that's why we say SHM is a type of oscillating. So the first condition satisfies. If the first condition satisfies, then we'll move to the next condition. Now, what is the next condition? The next condition is that, see, if this is the bob and it has reached this extreme position. Now see, why does this bob of the pendulum return to its mean position? Obviously because of the forces that is acting. See, this restoring force will be provided by different forces in nature that we will discuss later. Like in case of spring, if I say the bob is over this extreme position, what will happen? The gravitational force will try to bring it back down to the ground, to its mean position. So various types of forces will do the work of this restoring force. So this restoring force brings it back. Now, if the direction of restoring force is above, then you tell me, will this bob come back to its mean position, or it will go far away?
If the force is beneath,
If this is the condition, if the force acts in this direction, restoring force,
it will go farther away.
further away, it won't come back to its mean position. So in order to bring this bob of the pendulum back to its mean position, the restoring force has to be directed towards the mean position. Even if you take the example of this block of mass m, if this block which is attached to the spring, if I have taken it to this extreme end and this was the mean position, the direction of restoring force should be where? It should be direct towards the mean position. Then only the object will come back to its mean position. So this is the second condition of SHM, that restoring force should be directed, should act towards the mean position. So that act towards the mean position. Now, this is just a mathematical relation which says that whatever is the restoring force applied, this restoring force applied is directly proportional to whatever is the distance or the displacement produced, or the extension that is produced from the mean position. So this restoring force is directly proportional to the displacement. So in order to remove the proportionality, we put a k, a constant k, which is known as a spring factor. Now we just add this negative sign in order to show that this restoring force is directed towards the mean position. So the formula for restoring force becomes F equals to minus kx. Now this is known as spring factor, but don't get it confused with only spring. If it's spring, then the constant will have certain value. We call it as spring constant. If it's a different system, if it's oscillation in a liquid tube or any other through a tunnel, then the k will have its different value. So to generalize whatever is the constant, we call it as spring factor. But what you have to remember, whatever is the restoring force, it will be directly proportional to the extension produced or the displacement from the mean position. Is it clear now?
Yes, ma'am.
Any other doubts?
No, ma'am.
All right. So have you both copied this?
Yes, ma'am.
Yes, ma'am.
All right. All right. Now see, SHM has various characteristics. Amplitude is there, displacement is there, velocity is there. So let us understand the first one, the displacement of a particle executing SHM. Now see, this we have already studied. F is equal to minus of kx. Now from here only, let us continue. Let us continue this only. If F is equal to minus kx, then acceleration is force by mass. So if I write the value of this, acceleration will be what? Minus kx divided by m. Yes. Now see, acceleration is what? dv over dt, rate of change of velocity, or you can say double differentiation of the displacement. This is the basic, very basic physics that you have studied in motion in 1D already. Now see, if this is the value of acceleration and this is also the value of acceleration, it means both of these are giving acceleration only. That is minus k by m, kx, sorry, not km, minus kx by m, minus kx by m is equal to d square x divided by dt square. All right. Now see, if I bring this term along with this, it will be d square x divided by dt square plus kx by m. This is equal to 0. Now see, this k by m that we are getting, this is nothing but, you are aware already of this term, angular velocity. So the square of angular velocity means omega square. This is k by m. So if you have to calculate omega, that is the angular velocity, it will be k by m. So omega is the angular velocity. Also, you can say it can be said that it is the angular frequency as well. So this is angular velocity or the frequency. Now see, regarding this equation, k by m, I can write it as omega square as well. So this will be omega square plus x equals to 0. So this is the standardized equation, which you can say second order differential equation of SHM. Second order differential. Double because it is double differentiation. So this equation is known as second order differential equation of SHM. This equation is known as double differentiation of SHM. Now see, what is omega? Again, I'm repeating. Omega is under root by km. Under root divided by k by m. So what is k? K is simply the constant spring factor. M is the mass. Now see, if I take one more thing. Okay, this is already written over here. Actually, the solution of this equation. Solution of this equation. Solution of equation of SHM. This is given as x equals to a sine omega t plus phi naught, or as I've told you, this can be cosine curve as well as sine graph. So you can also write it as x equals to a cos omega t plus phi naught. Now see, this whole term that is coming under this angle sine theta, this whole angle, this is known as the phase. And whatever is this phi naught, this is known as the phase constant. So first understand what is A. A is the amplitude. Amplitude means maximum displacement, maximum value of displacement. Like if this is a wave, the particle has reached this point also. The particle has reached this point also. The particle has reached this point also. 1, 2, 3. Tell me from 1 to 3, which particle has covered the maximum distance?
3.
3. So we say this is the amplitude of the displacement. All right, maximum value of displacement from the mean position is known as what? It is known as the amplitude. Now see, these what I have written, these are all the SI units. So if it is a spring displacement, the A change will be in terms of position. In pendulum, the motion occurs and the change happens in terms of angle. Sound waves, there are changes in pressure. Light waves, there are electric and magnetic field. And I have written the SI unit. Position is meters, angle is radian, pressure is pascals, and electric and magnetic. For electric field, it is Newton per coulomb. For magnetic field, it is Tesla. So these are just the basic terms for which you all are already aware of. Now see, just an elaboration of angular frequencies, omega is 2 pi divided by t. And this t is again the time period, that fixed interval in case of SHM that we were seeing in case of periodic motion. Now see, omega and frequency are related as, see, frequency is inversely proportional to time period. If frequency is inversely proportional to time period, that is, it's the reciprocal of time period, then we can simply say omega is 2 pi nu. Now, nu is this frequency, this is the frequency, t is the time period, omega is the angular frequency, 2 pi is the constant used, and SI unit of omega is radian per second. Omega is basically what? D theta over dt. Theta is radian, so this will be radian per second. Now see, phase actually decides the evolution of time. Phase and phase constant, yes, this. Phase constant decides the evolution of time. Evolution of time in the sense at t equals to 0. Or what is the phase of the period? Like, is it in the fourth quadrant? Is it in the third quadrant? Why? How will we get to know? Because of the angle. Because this is what? Phase is what? This is sine theta ultimately. This is sine theta. Whatever is this theta, we have just elaborated and wrote it as omega t plus phi naught. Is it clear?
Yes,
And see,
ma'am.
phase constant means what is the state of the system? Means at t equals to 0, what is the state of the system? Like, is it at mean position? Is it at extreme position? Is it somewhere between mean position or extreme position? So how will we get to know whether the particle is at mean position? We'll simply put t equals to 0. So phase constant will help us to decide the state of the system. So just note down all these points, then we'll do one numerical.
Ma'am, can you scroll?
Done, ma'am.
Done?
Done, ma'am.
Uh, See, this is the first question. It says x equals to 20 sine 10t plus pi by 2. Okay, what is the amplitude? See, let's check the first. Let's write the standard equation. Whenever you are provided with any kind of this question, where you have to write the value of amplitude or some any other equation is given to you. So first thing which you have to do is what? You have to write the main equation, whatever is the standard equation we have. So since the question is given already in sign form, so we'll write our standard equation in sign form only. So this is a sine omega t plus phi naught. That's what you have written right now. Okay, what was A, Aisha? Aisha, you tell me, what was A?
Hyderabad. Yeah, tell me.
Yes, Aisha.
Ma'am, A is the amplitude max value of displacement.
Amplitude. Yes, right, amplitude. Okay, so compare it with the equation that is given in the question. What has been written instead of amplitude?
20.
20. 20 is written. So this means the amplitude is 20. So the answer to the first part is 20. And since this is given in meters, amplitude will be 20. Okay, Akifa, you tell me what is the formula of angular frequency? What is angular frequency from this? The screen, which you can see on the screen. What is angular frequency among all the variables that you have?
10t.
10t is omega t. Omega only is 10. This will be omega will be equal to 10 radian per second. All right. Time period. We have a relationship between omega and time period. Omega is 2 pi by t. So time period will be what? This will be 2 pi divided by omega. So time period will be 2 pi divided by 10, or you can say pi by 5 seconds. 1 by 5, pi by 5 seconds. So this will be pi by 5 seconds. Phase constant. Yes, Aisha, tell me, what is phase constant from this equation?
Pi by 2.
Pi by 2. See, from this equation, this is phi naught. So instead of phi naught, we have pi by 2. So phase constant, you are right. It is pi by 2. What is pi by 2? This is 90 degree only. So the phase constant is 90 degree. So this is a very basic question. Is this question clear? Okay, one
Yes,
more
ma'am.
thing before you note down. This is also a very important thing. See, in the later questions that we'll discuss, we have to identify periodic motion, non-periodic motion, SHM. See, the first thing that you should know is that periodic motions are sines or cosines, but they can be combinations of sines and cosine as well, like sine theta plus cos theta. If you see any kind of combination, then also you say motion is periodic motion. And if this d square x by dt square, when you take the double differentiation of the equation that has been provided to you, if that double differentiation is directly proportional to negative of the displacement, it means if it is satisfying this, like let's say y is equal to something is given, then you have to identify whether it is SHM or not. So what you will do, you will double differentiate it. Means first you will differentiate it with respect to time or whatever is the variable given, then you will differentiate it again with respect to time. If you see this is coming negative of this is coming directly proportional. There might be other constant as well. We have to neglect the constant and just have to look at the proportionality. This will get clearer when we do the questions below. So see, if you see this question, then we say the particular, this respective equation is in SHM. All right. Now see, regarding the non-periodic motion. If the periodic motion, if you see all the conditions which are given, which I have written, these are not being satisfied. So this means the motion is automatically non-periodic. It's a non-SHM motion. So all sines and cosines and their combinations are periodic. Second point, that double differentiation, just to check, you just have to, you can check whether the particular motion is in SHM or not by just taking the double differentiation. How you take the double differentiation? The way you must have calculated acceleration when displacement was given. Acceleration when displacement was given, what did we do? First we took velocity out of them. It means we used to first differentiate it and we used to again differentiate it. That way it gave us the double differentiation. So if this satisfies the condition, then we say respective body is executing SHM. Now see, let's take this example to understand what I was saying. Y is equal to sine omega t plus cos omega t. We have to check whether this is periodic. Okay, it can be periodic as well as SHM. As we have seen, SHM is a type of periodic motion. It's a combination of sine theta, it's a combination of cos theta. If it's a combination of sine theta and cos theta, what did I tell you? It is periodic, definitely. Yes or no?
Yes.
Now see, we have to, so periodic, non-periodic, this debate gets over. Obviously it is periodic. To check whether it is SHM or not, we have two methods. Okay. First, I think you should go for the second method, but let us discuss the first method as well. You can compare it with the standardized equation. Now, this is not in the standardized form. So what you can do, you have to first see it to it, that can it be converted in the standardized form or not? Like y is equal to sine omega t plus cos omega t. All right. Now y is equal to what? What can I do? Can I multiply and divide with the same term, that is root 2? Will it make any difference if I multiply and divide it with the same term? This will get cancelled. It will come back to what was the equation. Now see, if I take this root 2 within the bracket, if this is the bracket, root 2 will be left over here. If I multiply this 1 by root 2, this will be what? This will be 1 by root 2 sine omega t plus 1 by root 2 cos omega t. Yes. Now see, what can I write 1 by 4 sine omega t? This is basically, if I write it as, let me scroll it down. Y is equal to root 2. Y is equal to root 2, 1 by root 2 sine omega t plus 1 by root 2 cos omega t. What I have done till now, I have just multiplied this 1 by root 2 within the bracket. Now see, 1 by root 2 is cos 45 degrees value and 1 by root 2 is sine 45 degrees value. So what I can do in order to use this identity, a plus b is equal to sine of a cos b plus cos of a sine b. So in order to use this, I can write 1 by root 2, I can write it as cos pi by 4 because cos pi by 4 is 1 by root 2 only. So this way I'll be forming this identity also, so it will get concise. Because why? Why am I doing this? Because I need it in this form, sine theta. Otherwise, I won't be able to get the standardized equation. This will be sine omega t plus again 1 by root 2 is sine pi by 4 cos omega t. So this is satisfied. It means y equals to root 2 sine a plus b. A is what? Omega t. B is what? Pi by 4. So again, have we received our standard equation?
Yes.
So is it an SHM or it's a non-harmonic motion?
SHM.
SHM. So this is also a method you can get stuck somewhere in between in this method, because what to multiply, this is the tricky game. Which number you should multiply in order to obtain the identity. So it's a hit and trial type. But the standard and foolproof method that will not go wrong, that is this one, the second method. Means taking the double differentiation of the term and then checking whether it is directly proportional coming to the negative of this displacement. Like if I tell you why this was method 1, if I write for method 2. So our aim should be just to check if this is coming. This is directly proportional to minus of y. Then I will say what? Then this represents SHM. So till here it is proved already. This is representing SHM. This is already proved over here. So let's take the double differentiation of it and let's check whether it is coming in SHM or not. So the standard equation was y sine omega t plus cos omega t. Y is equal to sine omega t. Just a second. All right. Okay, so the equation was what? Yes, sine omega t plus cos omega t. So I will have to differentiate it first, dy over dt. The constant omega will come out. Sine omega t will be cos omega t. Now for cos omega t, it is omega will definitely come out, but a minus sign will be there when we convert cos into sine omega t. Then dy over dt, this will be equal to omega. I can take omega common. This will be equal to cos omega t minus sine omega t. Now see dy over dt. Now I have to double differentiate it. Means I have to differentiate it once more time. So this will be what? Omega will come out again. Again it will be minus omega sine omega t for cos omega t. And it will be minus omega cos omega t for sine omega t. Why? Because when we differentiate cos theta, it's minus of sine theta. And when we differentiate sine theta, it is positive plus cos theta. And since omega is constant, that's why we are taking get it out. So see d square y by dt, this is equal to, again, let's take omega common. This will be omega square. What are we left with? Sine omega t. And we have taken minus already common. So here it would be plus cos omega t. What was our initial equation? This was only y. This is the constant. So d square y by dt square is directly proportional to what? Minus of y or not? Yes.
Yes.
Yes. So that's why this again proves that this is in simple harmonic. Now here we have not calculated the time period. Just to make you clear how to calculate the time period, like if this is an equation, I've already written that it's not in SHM. When you'll prove it, it will come out not to be in SHM. It is a periodic motion, as you can directly see. It is a combination of sine and cos. Here, what I want to tell you is that how to calculate the time period. Like y is equal to sine omega t. Omega is 2 pi by t. Here is what the case. This is omega is 2 pi by t. The time period will be what? T 2 pi by omega. This will be t1, time period for this particular trigonometric function. Now see, if we take it for this 2 omega is equal to what? This will be equal to 2 pi divided by t 2 times. If it's 2 omega over here, you will write it as 2 omega over here also. But here also the time period will come out to be what? 2 pi divided by omega only. For T3, that is omega is equal to 2 pi by t. Here also T3 will also come out to be 2 pi divided by omega. So we say the time period of the system is t only. That's why we take a common time period. The reason for choosing the common time period is simply this only. Because we choose a single time period that is common to all the terms. A single time period that is common to all the rest of the terms. That's why we say time period is t. So this is clear. Main question was this only. The second question. Identifying periodic, non-periodic SHM. This one, this question. Clear?
Yes, ma'am, clear.
All right. So note it down from this question.
Ma'am, can you scroll down? Ma'am, can you slow down? Done, ma'am.
Yes, completed.
Yes, ma'am.
See, one more thing that you have to know, that in case of exponents, when exponential form is written, then that period is non-periodic motion. So ultimately it will be non-SHM. This is applicable in exponential form as well as in logarithm form. If you have any equation like y is equal to log wt, the way I've written it over here, this, it will also be non-periodic and obviously in non-SHM. One more thing, one more numerical, just in order to clarify this concept. This is definitely periodic. It's a combination of sine and cos. It will be periodic. But all periodic motions are not SHM, and that can be proved if I take the if I take the first differentiation of this. It will be minus omega sine omega t. Then over here it will be plus 2 omega will come out to this, and this omega will come out, and it will be sine 2 omega t. Differentiation. Now the double differentiation of this d square y t will give me minus omega square cos omega t plus 2 omega, again 2 omega this term, and now it will be cos 2 omega t. So is it in this form, minus d square by dt directly proportional to minus y? No, minus our y was this. So this is not being completed. So we say this is not in SHM. So this is an example of the motion in which the motion is definitely periodic, but it is not executing simple harmonic motion. Clear or not? Is this clear?
Yes, ma'am.
Yes, ma'am.
Just note down this as well. Rest of the things we will continue tomorrow in the next class, next week.
Done, ma'am.
Both of you?
Yes, ma'am.
Fine. Then let's meet in the next week. Just revise these basic terms. We'll complete velocity and energy and rest of the terms.
Thank you, ma'am.
Thank you, ma'am.
Okay. Okay, love.